Tech Nuggets, DHCP. DHCP helps solve one of our chicken and egg problems when it comes to even small networks have this problem, like at your home or somewhere like that. It solves this problem of plugging a new machine into your network and how does it get an IP address? Clients and servers both need IP addresses, but the truth is we only really care what the IP address is of the server. Clients, which are the vast majority of machines on the network, really don't care what their own IP address is. They only need it so that they can have unique communication with a server, a printer, a file server, a web server, some other device that's offering a service. And in that case, those devices on the network need unique and non-moving IP addresses. And we'll talk about what non-moving means. So it helps solve this chicken and egg problem. DHCP stands for Dynamic Host Configuration Protocol, and it helps dynamically configure an IP address on our client machines. When we do the Wiresharking later, we'll see this other acronym called DORA, and some people confuse it. That stands for the 4 packets that go on in the Wireshark that we'll see, which is a discover, an offer, a request, and an acknowledgement. A little bigger discussion about where does DHCP fit into our IP architecture, and that means like when we've laid out our subnets and we're allocating IP addresses in our documentation, where does DHCP fit? And earlier in our subnetting discussion, we talked about this convention that we use. And normally, static addresses are at the very beginning of our subnet, and we may or may not have a gateway that's the last usable address in the range. That happens to be the convention we use. It's not the convention everyone uses. But DHCP, and they're called DHCP pools or lease pools, tend to exist in between the statics at the beginning of the range and maybe a small range of statics at the end of the range. And they kind of live in, well, ranges, long groups of them that would be in there that our DHCP server will use and hand out and recover. And that's what our DHCP server does, is the client and the DHCP server have a discussion, and the DHCP server gives the client an address for a certain amount of time. And the client may leave and come back and that kind of thing, and it may get the same IP address or it may not, which is the joy of DHCP. The DHCP server will recover those addresses and reissue them to new clients as needed. If we have too many clients, we'll exhaust the pool, and then we have a problem because the DHCP server will run out of addresses to hand out if there's too many clients that show up. This can happen in a wireless interface, so that tends to be where we get lots of phones and laptops and tablets, and they show up and all of a sudden, wow, I ran out of IP addresses. I didn't realize that. So some amount of monitoring of our DHCP server is required. Our DHCP server can also hand out things called DHCP options. So other things can be handed out with the IP address. What are my name servers? What's my gateway? If we're a specific device, and the VoIP telephones tend to be this way, where can I find my SIP server? Where's my TFTP server to begin to pull configurations for my handset? Things like that can also exist in our DHCP server, and so handing out DHCP options is not unusual. When we get to the practical piece at the end here, I'm going to use VyOS to implement a very simple DHCP server, and we'll do that in GNS3 with some practical demo and some Wireshark so that we can see DORA and we can see some of the options fly around and things like that. So on to the practical part. All right, so here we've got my trusty GNS3 VM, and I've pre-set up and made sure that this all works. Our setup here. So what we're looking at here is we've got an internet cloud here that connects to our VyOS router. It has connection to an Ethernet switch, and we're going to use a VPCS. And I've opened the consoles to both of these just so that we could see them. I did the basic VyOS config that you would have seen in other labs and other videos that we've talked about, where I configured the WAN interface and a LAN interface. So that we can use VyOS to do DHCP on the LAN side. You can see here I've got the config showing where I've got 192.168.1.254 on our LAN side, so that'll be off of ETH1 here toward our VPCS, and I'm just doing DHCP on ETH0 toward the internet, and that's being provided by my internet cloud in this case. Our VPCS is not configured at all. I just turned it on. There's nothing here. We can do commands that will show us those oops, show IP, and it'll show us our IP address. So you can see there's nothing configured here. It has a MAC address and some other basic settings, but nothing else is configured or ready to go. All right, so let's hop in here. You can see I'm in config mode since I have a little edit over my prompt there, and we'll start, configuring DHCP. The basic commands set up the pool and then define the start and ends of the pool, and that is only 2 commands in this case. And I will type them in. And we're going to name our pool. So this is a, this is a variable that I pick. LAN pool, it's a pool of DHCP IPs, so I picked LAN pool. I think if it's got spaces in it, you're going to need quotes around it. So if it's a LAN space pool, you might need single ticks around it or something like that. But if you keep it to one word or something that's hyphenated with no spaces, you should be okay. Authoritative. This enables it. Once we committed, it would enable it. And the second one, and every time you issue a command, it has to start with set service DHCP server shared network name LAN pool, so it knows which pool, because you might have multiples if your VyOS has multiple interfaces or something like that. And we're going to tell it what subnet we're using, and in our case we're using 192.168.1.0/24, and we're going to say where the IPs should start. So we give it a start address, and in my case I'm going to start at 128, so halfway through the subnet, and I'm going to stop just before the end, which is at 250. So that leaves me, 4 addresses if I need to, my gateway's in there, right? It's 254, because that's our convention. But this gives me a couple addresses to play with at the end if I need, for some reason, a static at the end of the range. So we'll do a show, and we can see it here. And you can see the in-service DHCP server. It's added all the different steps, and the plus means it has not yet been committed. So we will commit that. All right. And that should give us a DHCP server that will start handing out addresses in a basic format. And we're going to go over to our VPCS and make it do it. And when VPCS turns on, it doesn't do anything. It comes up very blank, doesn't assume that you want anything. A lot of operating systems are predefined to do DHCP, which is one reason most users never notice. They turn it on, they connect, and poof, it just magically has an IP address, and that's because it comes pre-configured that way. VPCS is a diagnostic tool and a training tool, so it comes not doing anything unless we tell it otherwise. So we'll type DHCP to get the DHCP process started. And you'll see here, it's going through the DORA process. It sends out 2 discovers, and then an offer, a request, and an ACK. And we'll Wireshark that here in a minute so that we can see what there is to see at a Wireshark level. And you can see here, I got back an IP address. So before I had nothing, now I have an IP address, and it gets a little more information. It can tell me what my DHCP server was, how long my lease is, what my MAC address is, which of course was listed earlier. So now we should be able to do things like ping our gateway. All right, there we go, we can ping our gateway. There are a number of options here that we can hand out in order to make the client much more functional. And I'm going to go through some of those options, especially the basic ones that we're going to want. And we're going to talk a little bit about how to manipulate and monitor and work with the DHCP server itself. All right, so now that we've got DHCP doing its thing, handing out IP addresses, let's go back to our VyOS box and have a little look. How do I tell what it's doing? I want to look at its statistics. And unfortunately, these are not commands you can issue in config mode. So you have to exit config mode to be able to do some of this stuff. And it's going to complain that it hasn't been saved. And in our case, it's a lab environment. We're not super worried about it. But we would use the save command to save all of our cool updates to the startup config if we needed. So we'll exit config and we'll do show DHCP server. And one of the first things, if you tab here, you'll see there's a number of options. And we're going to go with statistics at the beginning to just give us some basic understanding. So it's going to list the pool, it's going to list the pool size, it's going to list the number of leases it's handed out, and what's left. So we had 123 leases and we handed out 1. So if we had multiple leases, we'd be able to see it here, and that's useful. Another one that we can get is leases, which will give us a lot more information about the leases themselves. It'll list things like who got the lease, what IP address did I hand them, what's their name, from what pool, when does it expire, so if I'm worried about moving, changing my leases around and that kind of thing. And you can see here that our VPCS showed up and the MAC addresses match. So we can tell that VPCS showed up and got an IP address and when it's going to expire and things like that. There is a way to reset the DHCP leases in case you need to do that, and we can do reset. DHCP server leases, and it's plural. If you do singular, you have to list an IP address and it'll kick that one out. If you do leases, it will kick them all out, and there's no feedback. It's very disruptive that way. But if we go look at our leases, we'll now see it's blank, which is kind of unfortunate for our VPCS that doesn't know any better. It's still holding on to that IP address, thinking it's mine, it's mine. So you should probably go back and do another DHCP just to make it do that. Now, the good news about the VPCS is every time I type DHCP, VPCS will go back to the server and redo the entire DORA process, which is great when we want to Wireshark it, we'll look at it and talk about it. It's a little less great other times, but we'll talk about that later. All right, so other options that we want to give it. We want to configure options, so we'd like to give it like a default route, because right now I can't go anywhere. I can't get to the outside world, right? If I type, right, I want to ping, it's going to say, hey, I don't have a gateway. I don't know what to do. One of the options that we can hand out when we do this is a gateway. So we'll go in and say set service DHCP server, P server, shared network name, LAN pool, subnet, and we're going to give it the default router option, which is the same as a gateway. Those are interchangeable terms. And of course, we're going to list ourselves since we're the router and the DHCP server. That's not always true. We can have separate DHCP servers, but in this case, we are the DHCP server and the router. And we'll do that and commit. And now at this point, we have to go back through the DHCP process so that it will pick up that option. It's not magic. It will not. It will only hand it out during the DHCP process. So we retype DORA or DHCP. We go through it. But now when it comes back, and you'll notice it gets the IP address, it actually lists a gateway. And if I go back and ping 8.8.8.8, it will ping. So we'll be able to get somewhere now as we hand out different options. Several other options that are super useful are things like, gosh, it'd be nice to have a name server. Can't resolve, no name server, sorry. Well, okay, let's go back and, give it a name server. All right, so we'll go back and give it a name server here. And there we go. So oftentimes, most of the commands here will go from this point forward where we've specified the pool and the subnet, and from there we can do most of the other options. So we can say things like DNS server. And we get a DNS server. And again, we'll have to go back to the client and tell it, hey, go get, go get the options again, go get it all again. In the real world, oftentimes this would be enabling or disabling the interface, or maybe even as much as unplugging, waiting a couple of seconds, plug it back in. Takes a little while for the Ethernet card to figure out what's going on and the operating system to figure out what's going on, and there can be some timing that goes with this that can be kind of exciting. And there you go, you can see we're resolving. One of the better test tools that can go with this, and we talked briefly about it when we were looking at the statistics, was how long do I get this IP address? It is not forever. It is not a statically assigned address. The VPCS or any client that uses DHCP gets a lease time. It's just like renting an apartment. You're allowed to have this from X to Y, and after that, we need to talk about it again. And there's a process that goes on for renewals that we'll talk about. We'll Wireshark here in a little bit. But we're going to shorten our lease times. Normally, lease times are given in maybe a day or 2 or 3 days. And the client and the server, at about halfway through the lease time, they renegotiate to make sure that everything's still okay. Can I keep my IP address? Yeah, you can keep your IP address. That kind of thing. So we're going to shorten our lease time so that cycle happens more often and we can Wireshark it and see it. So we'll go back over to our server here and we'll edit the lease times to 120 seconds. So that'll be really brief lease times, which makes the network really, really chatty, and we don't normally want that. And again, if we were to say, show me my IP settings now, we would see a lease time that's fairly long, right? It's 86,000 seconds. That's about 24 hours. But if we go and do DHCP again, and then do a show IP, it should get considerably shorter. Right, 117 seconds. So it's telling us that it's 120 is maximum, 60 is halfway, and I think we're at 105 or something like that. I'm not quite sure why it has 117. There may be some transit time from when it started or something like that. All right, so next up, we're going to Wireshark this. So we're going to reset our VPCS. We're going to leave our options in the server, so that won't be as big a deal, but we'll start some Wiresharks, and then we'll get the VPCS going so that we can see different parts of what's going on with this DORA process, and we'll explore the renewal process as well. All right, so I've moved my terminals around a little bit. I've got my VPCS over here since we don't need to see the VyOS terminal. It's already kind of set up and ready to go. I've cleared its IP address by typing clear IP, which blows away all of its IP settings, so we'll stop trying to DHCP and things like that. So we're going to start up Wireshark, and I'm going to highlight the line here and right-click and say Start Capture. It's going to bring up a dialog box here asking me where do I want to do it. I want to make sure the Start the Capture Visualization Program, which in our case is going to be Wireshark, is checked, and we'll hit OK. Go back and bring up our console, and this should start Wireshark, and it'll take itself a little ways to heave itself up off the ground. So one might need to be patient with that. All right, here we go. So Wireshark pops up, and I've stretched the window a little bit so that it's an appropriate size and that kind of thing, and we can see what's going on. So at the top will be summary lines, and the middle will be other things as we go along. So at this point, I'm just going to go over and type DHCP, and we're going to see what happens. Right, all of a sudden packets start flying along, and we can see the DORA is going along on the VPCS, and pretty soon it should finish up. All right, well that works pretty well. As you can see, I've minimized the raw data window here. I don't usually need to see much of that, and I've got my summary data up here. And we're going to use a packet filter. DHCP is based on an older protocol called BootP, so the filter for this is not called DHCP, and that's rather unfortunate. It is in fact called BootP, and you can tell it turns green when I type it there, and we'll hit enter. And so you can see that there we go. We've got our things going on. I'm actually going to clear the IP here address so that it will not do any of the renewals. So I'm going to stop that here just so we can look at the DORA that goes on, and it won't continue to generate packets and be more confusing than it needs to be. So we can see when we did our DORA on our client, it did 2 Ds, an O, an R, and an A, and that's what we're seeing over here. And sure enough, when we look, we can see 2 discover packets, an offer packet, and a request packet, and an ACK packet. And since I've got my filter on, that's all we're going to see. We're going to be able to go in and look at some of these packets and sort of discover what am I asking for, and what am I looking for, and what's it doing. Also, as we go along, we'll see that some of these fields will fill in with more and more information as more and more is known. So we'll see different options open up, and we may need to open up some of these options things to see what's going on. So some of this information comes along where we can see it's giving out its host name. PC-11 is the VPCS's name. I'm not quite sure why. It must have randomly picked that, but it also gives its MAC address, and we can see it does that a couple of times. And in fairness, if there's no DHCP server on the network and an Ethernet card is configured for DHCP, it will just continue to send discovers. It sends a flurry at the beginning, and then it will slow down to about every 30 seconds. An Ethernet card will spit out a discover, just checking to see if a DHCP server, woke up or showed up or something like that. And so it'll spit traffic out like that every once in a while. You can see we move down to the offer, and this is where the VyOS has responded back to the other end. So it's responding back and giving it the options that we sent. It's asking for options, it's getting options. We can see this all hides under the bootstrap protocol that's BootP. So when we go to look at DHCP, we sort of have to look through that kind of stuff, and we can see there's an offer here and that it's offering a lease time of 120 seconds, 2 minutes. We're offering subnet masks and routers and IP addresses and name servers and all those options that we put in, but no more. So that comes in the offer. This is the DHCP server saying, hey, these are the things I can give you. I don't have any others, but I can give them to you. And when we get back, this is our client saying, okay, here's my request. These are the things I want. And it will ask other than IP address. So it will ask for, yeah, I'll be happy to take the IP address you offered me, as well as these are the other options. I want a subnet mask, I want a router, and a domain name server, and a domain if I can get it. We're asking for things we aren't getting, right? Domain names aren't something we were offered. Domain name servers were, but not a domain name. At the end, there's an acknowledgement that comes from the server that says, yep, here's all the stuff I can offer you. Here's how it all works. You use it the way you need to. It's the things you ask for that match up between the things I can offer and the things you ask for. All right, so I've reset our setup, and we're going to do something a little different this time. We're going to set it up, and we're going to let DORA happen, and then we're going to watch for the renewals that should happen about every 120 seconds. So I'm going to my client. I type DHCP. We can see what's going on. We'll go up and put in the boot P filter. So we only have to see DHCP things. Make that a little smaller. This will take a little bit, right? It should take about 60 seconds for this to happen. So we'll speed time up a little bit. Okay, so there it is. We can see that after the last, DORA goes on, and then later, about 60 seconds later, by the timestamp, you can see that there's a request and an ACK. If we were to look at the MAC addresses on our request and ACK, we'll see the MAC address comes from our client, 68.00, which we can see here in VPCS. I ran a show IP. And we can see that it's communicating with E089, which is VyOS, and it's making a request. It's checking in to make sure, hey, can I keep all this stuff? This is my IP address. You can see it down here under client flags and things like that. I'm requesting any new things that might come along. And we see back from the server, it says, yep, you're fine. Keep it. It's not a problem because it doesn't change its IP address. It says your client IP address is the same. If it were to say, no, the pool has changed, you're going to need to give that up at the end of your release time, we would see something different happen. There you can see another request and ACK just hopped in as we were talking about, 60 seconds later, so half the lease time. So while it may be able to keep that that IP for the entire 120 seconds, it checks in at half to make sure we haven't changed the pool sizes. And we could go change the pool sizes and make that IP address not part of the pool. And DHCP would go through a process of giving it a new IP address if it needed it. Remember, for the most part, clients like the VPCS, they don't care what their IP address is. They're going outbound with it. So it won't matter if their IP address changes all that much. For the most part, this covers the basics of DHCP and the Wiresharking of it. It covered, VyOS and how to set up VyOS and work with that. We did some basics with the VPCS. I hope you've enjoyed the video. There'll be more. We'll be doing NAT, which was used in this, but we really didn't cover it. But we'll talk about how NAT works in one of our future Tech Nuggets. Have a nice one.